Okay, good evening friends. So crack this problem first. Yes, please do this and everybody tell your answer. Don't worry if it is wrong. And I would like to know who has done it correctly, who has not done it correctly. If you have not done it correctly, I am here to help you. So a needle is floating on the water. If you keep a piece of coin or something, it will sink, isn't it? But why will a needle float? Due to surface tension. Okay, I hope you can explain this, right? So, can anybody explain this surface tension for a needle? So, this is the surface of water, which is flat, right? This is water surface which I am drawing here, surface of water. Can you see any tension here, surface tension? I don't think you can see any surface tension visibly, right? Hello?
No, sir.
Yeah, there is no visible, there is nothing visible to say that, there is some surface tension. Yeah. But however, you see, if you keep a needle on this, right? If you keep a needle on this, so I will draw one more diagram for this. So if you keep a needle, I am just showing it big. I am showing the cross section of the needle, right? Now you will find that the water surface is like this. Hello? Clear? The water surface is like this, and this is the needle. I am showing you the cross section of the needle. So, well, now where is surface tension, vagera? Please tell me. Come on, have a clear understanding of this. So, if you see the surface from the top view, from this view, right, you will see the surface of water is like this, right? The surface of water is like this. Now, what you have to understand is that there is a phenomenon called surface tension. Okay, now what is this? How does this phenomenon called surface tension arises? Can you tell me a few sentences about it? Anybody? Come on.
Due to adhesive force between the molecules.
Who is that telling? Who is that telling? Who is that? Identify yourself. Come on. I would like to. Adil, you said adhesive force? Adil?
No, sir. Due to cohesive force between.
What's wrong with you? There's a huge difference between adhesive and cohesive. Come on. Right. Cohesive force. Right.
Due to cohesive force between the molecules of water, sir. If you draw an imaginary line passing through the surface of the water, the molecules of water will attract each other, which will create a tension in that imaginary line.
Can anybody throw some more light on what he has told? Come on, everybody participate. I am not convinced with his answer.
Sir, like all the molecules of water will attract each other, sir. But on the top layer, water is attracted only from the water that is there below, but not there is no other force acting above it. And because of those forces, there will be a tension that will be acting.
How you say? There is no force on top. How will there be tension created there?
Because of the other molecules of water that are present below it, there will be force acting on it. Because
no. If you take another molecule down here, these are the molecules here. Okay. Now these are also attracted. These are also attracted by the neighboring molecules due to cohesive forces.
So, but if the net force
net force is 0.
Okay, net force is 0. So okay, fine. So if you take a molecule here, its net force is something here, correct? So if the net force is something here, so why will there be tension? The surface of the liquid will behave like a stretched rubber membrane, correct? That's how it is defined.
Yes.
So if the forces are acting down, the net force is acting down on the molecules, why should the force on the surface be, in this direction? Because that is what you do, isn't it? The surface you say that, if you draw an imaginary line on the surface, you will show the surface tension forces like this. You are showing the surface tension forces like this, isn't it? That is, you draw an imaginary line and show the surface tension forces, and if you take all these forces put together is force F, and if the length of this line is L, so you say now the force per unit length, you call it a surface tension, correct?
Yes.
And surface tension forces are due to cohesive forces, correct? And it is tangential of the surface.
Yes.
Right? And this is how you are showing it. My question is, well, you didn't complete the answer. If the forces, if the net force is down, why should the membrane above, the layer of the molecules on the surface, behave like stretched membrane?
It will always try to achieve minimum surface area over this.
No, okay, minimum. Why should it achieve minimum surface area?
It will be a state of minimum energies.
Why? What is the state of minimum energy? What is the state of minimum energy?
Sir, we had discussed in classes.
No, you tell now. You don't tell me. See, you don't take the discussion somewhere else. You discussed in the class and all. Why there will be minimum energy? What do you mean by minimum energy? When I ask a question, you simply think about answering that. Well, you see, I have done my best. I have taught all these things in detail. We have solved very interesting problems. About 6 months ago. And in the college also you have learned. And besides that, as a revision, I gave you a nice video containing the synopsis of this chapter, and I asked you to go through that. Correct? But in spite of all my best efforts, you are not doing your homework. Okay? You are not doing sincerely, honestly. Right? Because all these things are very nicely, present in the notes, and if you had taken a lot of interest and if you had read it, then these questions were not difficult. Anyways, that's how you are. Now let me tell you. So as you can see here, these molecules at the surface, you said something correctly about it, that the net force is down. I agree. But before it came to the surface, these molecules were down here, right? These molecules were just near the surface. Okay, just near the surface. Okay, so therefore, as the molecules which are very close to the surface, they don't have molecules above this to have the cohesive forces, and therefore the net force is down. But even though the net force is down, these molecules will rise up against the cohesive forces, against the net cohesive force. And that's the reason the molecules on the surface become very special, because they have potential energy. Clear, students? Because these molecules, against the net forces, it has risen up. The interior molecules have come to the surface against the net force acting downwards. That is why they have potential energy. Correct? Hello?
Yes, sir.
Yes, fine. Now everybody can say yes or no. At least you have mouth. God has given you mouth to say yes or no. Now let's come to the a theory which is universal. That is, whenever a system has there is potential in the system will always adjust itself such that the potential energy is minimum. Okay, so the potential energy is minimum. So when will the potential energy of the surface become minimum? When the surface molecules are minimum. When the surface molecules are minimum, only then the surface, the potential energy of the molecules in the surface will be minimum. Therefore, it will try to make a surface whose area is minimum. The surface area is minimum. Okay, then only the number of surface molecules will be less, and therefore the potential energy will be less. And in the process of making a surface, the area of the surface small, it will stretch itself. Okay, see, now if I have a surface of glass, if I put a drop of water here, so if I put a drop of water, the drop of water should have spread across like this. Then if it had spread across like this, then the area is so much. Okay, instead this drop of water, it will try to form what? It will try to form minimum surface. I hope you got this. Hello? Okay, it will form minimum surface. Okay, this is how the surface of the water will look. Okay, understand? So therefore you see the area of this is less than the area of the water if it gets spread. And in the process you see this, see here the membrane is not stretching, but here the membrane is stretched. Okay, and that stretched membrane, I mean this is going to behave like a stretched membrane where the force at each point is tangential to the line drawn on the surface, and that is surface tension. Is that clear, students? So you have to tell it these in steps. The most important thing is this molecules will rise up to the surface against the net force, net cohesive force acting downwards. That is why it has potential energy. And so all the molecules on the surface has potential energy. And now as a system, if the potential energy has to be minimum, the surface molecules have to be minimum. If the surface molecules have to be minimum, the surface itself has to be minimum. So in the process of adjustment, the surface becomes minimum. So the surface behaves like a stretched membrane, and therefore there is tension in the surface which is tangential. And we define it as F by L is equal to T. Clear?
Yes, sir.
Now, another way to look at it is, when you have, say, a soap bubble, say this is a soap bubble, soap bubble, right? Okay. So this has got some surface area, this has got radius R1, okay, and well, it has got a surface 4 by R1 square, right? And the molecules on the surface has got some energy, so let that energy be S, okay, let that energy be S. And now if you take the surface energy per unit surface, so what is it going to be? It is, you have worked out in the theory that this is going to be what, this by this is going to be again the surface tension. So therefore surface tension is equal to surface energy by area, and that also equal to the net force along the line, okay, drawn on the surface of length here. I hope this basic formula everybody knows, right? Fine. Okay. So now if you keep a needle on the surface of water, it will form a surface like this. And now tell me how the surface tension and the needle is balanced. I hope you understood though. This is the cross section of the needle. And this is the water surface. Okay, so now tell me, show me the surface tension forces here. The needle is floating on the water. So you have not done any homework again.
So like the molecules like which are in contact with the surface of the needle, sir, those are being attracted by the molecules beside.
Okay.
So they create a tension along the line passing through the needle.
Passing through the needle.
Like if you take a top view, sir.
Now here in this view, can you show me the surface tension vectors in this?
Like surface tension vectors is like along the curves like this.
So you should tell no. So you can tell no, sir. Draw a line. So you can very well tell me no. Right? You can very well tell me, sir. Draw a line like this. Correct?
Yes, sir.
Then why didn't you tell? Why don't you tell if you know this, right? So yes. So therefore now, if you take the vertical component for all these surface tension forces, right? See, these surface tension vectors are like this. This is holding like this, right? Okay. Then the vertical component of all these things, if you take the vertical component, that will be equal to mg, the weight of the needle, and therefore that needle will stay floating. Correct, students? Right. But if I put a coin or say some other lump material, it will sink. Why will it sink? Why this needle is floating?
Sir, there is only limited surface tension force. Limited force that the surface tension can apply. If mg will exceed that minimum value.
That's right. So therefore, the vertical component of all these tension forces, if it is equal to mg, it will float. But again, as your friend rightly said, that this vertical components of all this, if it is less than mg, then obviously the surface will rupture and the material will go inside and it will sink. Clear? Okay, fine. Well said.
Yes.
Right. Now, can you solve this problem?
Yes, sir.
What is the answer?
Sir, it is option A.
Option A. Okay, the length of the needle floating on the surface is 1.5 centimeters. Length of the needle is 1.5. Okay, and addition for the force in addition to the weight required to lift the needle out of the surface. Surface tension of water is so and so. So, what did you do here to get the answer? So, therefore, as you know, in a needle, if you take a needle like this, there is surface tension forces at all along the length. Okay, so therefore, the surface tension is what? T is equal to F by L. Right? Now here the total force must be equal to the weight of the body. So the total force is equal to weight of the body. So and what they have asked here, the force in addition required to, you have to find this force. This force will be equal to the force with, this force F that you are going to see here is the net force in the upward direction. So this will be equal to T into L. T here is T, but L here becomes 2L because the length of the needle is this side and this side. So there will be this one like this, and therefore you will write it as 7.5 into 1.5, both are in centimeters. So 1.5, write it as 3 by 2, right? Okay, and thereby solve the equation here. 3 5s are 15 and carry 3 7s are 21 plus 1, 22.5 by 2. Into 2 is there, this 2 will cancel, so you will get 22.5. Here is the check. Okay, clear students? See, yes please. Yes please.
So while picking up, sir, in that previous they are given that extension actually acts downwards, sir.
No, there is some audio problem. Please once again repeat your question.
So while in that video, sir, in that video, they are shown that when picking up the needle, sir, the surface tension will act downwards. So like how it is acting on that?
If you draw the diagram, you will get it. If you draw the diagram, you will get it. If you draw the diagram, you will get it. Right?
Sir, but won't there be a role of adhesive forces also?
No. See, now, yes, there will be a role of adhesive forces because there are two different materials, needle molecules and these molecules. There will be. But we account for the adhesive forces for the shape of the surface there. But in this case, with surface tension forces only, you can handle this problem. Okay, see, your question is good and your observation is also very good. I will appreciate that. So you have the cross section of the needle here. Okay, and I am going to show the water surface like this as it is before. Okay, now I am showing here what that the needle is supported. The needle is supported by the water. Okay, and therefore I am showing these forces. Clear? Hello?
Yes.
See, now it is like this. Your imagination is important here. Okay. Now supposing you take a handkerchief. You put some heavy thing in the middle, and then what do? You hold the edges of the handkerchief. Right? So what are you doing here? You are trying to stretch the handkerchief like this so that the weight at in the center of the handkerchief is coming up. Correct?
Yes.
Understood? You understood? So that is precisely what is happening here. The water surface is stretching like this, and this needle is being hauled up. Okay? That is precisely what is happening here.
So, but while picking up...
we'll come to that. You understood this phenomena?
Yes, sir.
Okay. Now that you know what you are going to do, you are going to apply an upward force. Okay. Now what happens is, as you increase the upward force, at a point when upward force is equal to mg, upward force is equal to mg, fine, that is one thing. Now what happens? This needle starts coming up. Correct? Hello? So I will now draw the needle like this. I will draw the needle like this. Okay, and it is just on the surface. Can you see here?
Yes.
The needle is on the surface. Now you see how is the water aligned to this? It is aligned like this. Now the contour of the water is like this. Understood?
Sir.
Okay. So your needle now is like this, right? And the surface of the water is like this. Okay. Now how are you going to show this? Well, you are going to show the surface tension vectors like this. Hello? Got it?
Yes, sir.
You understood?
Sir, at this position, sir. So that water is like attached to that needle due to adhesive forces between water molecules and needle molecules.
Correct. See, listen again I'm repeating. This adhesive forces here will determine this angle of the concavity.
Yes.
That's why we are using the adhesive forces there. Understood? How much concave? So that will determine the angle made by this net force with respect to this. That is all. Okay?
No, they will have no role in that.
It will have a role. It will definitely have a role. Because you see, ultimately you see it is, if this angle is theta, what is this F equal to, what is this net force down equal to? It will be equal to T cos theta, no?
Yes,
This theta will be determined by the adhesive and the cohesive forces. It will have a role, definitely.
Yes, sir.
Got it? Huh? So you see, everybody here, it's a very nice question that he has asked. So here you see, if you have questions like this, you make a drawing. See what I did now here is precisely what you can also do. You don't get stuck with the problem there. When you have a problem, okay, when I'm pulling it up, well, what happens? Okay, oh, I saw a diagram where the forces are being shown down. So when the needle is floating, you are showing the surface tension like this. When the needle is coming up, you are showing it like what is it? Now you observe very carefully. When the needle is up, you are showing the needle just touching the surface. Okay, and when the needle is floating, you are showing it like this. And then obviously you will draw the vectors accordingly.
Yes, sir.
Got it? That's how you have to learn physics. That is the maja of physics. Okay, done. Thank you. Shall we proceed, students?